So, hello everybody from my side. I'm Leo Schreiner. I'm an engineer at g.tec and I work mostly with the Unicorn device, and a lot of people of you today will use it. I guess maybe some people already used it. We brought a lot of devices, so I will give you now a brief introduction, but whenever there are questions, just come to us and we can deal with that and help you with the projects and on Discord as well. So the Unicorn Hybrid Black, as you can see on the screen, and Christoph already showed it, is an 8-channel BCI device with hybrid electrodes. So it features dry and wet technology. So we use it with and without gel. And it has 8 channels and 24 bits and a sampling rate of 250 Hertz. And we have a lot of software tools that you can use with the device. So here a detail again of the electrodes. You will also see it when you hold it in hands. You have this slider that you slide on and off the electrodes, but we have those fixed standard positions on the cap, which are mainly occipital. We also brought some standard EEG caps, so if somebody's interested to do his own setup, we can also work that out. But generally, we have a fixed setup with 8 positions that are mainly occipital. And when it comes to the software, so that's how the package of the Unicorn Hybrid Black looks. We have the device, the cap, the electrodes, and we have electrode stickers. So we have those standard ECG electrode stickers for ground and reference that we use on the mastoid. So we stick it here for our reference potential. That's how the system is used. And we also provide some gel. So I will also show you how to fill the electrodes with gel. It's just standard wet EEG electrodes that we can do. And for the software, we have a lot of different software included. So for the hackathon today, you should make sure that you get the Unicorn suite downloaded. It's on the GitHub. The chat will be provided. Ah, okay. I didn't even know that this was on the main screen. So the presenters. Yeah, okay.
I think you switched.
Maybe Chris, if you can make it a bit bigger so you can. Exactly. Perfect. Thank you. Yeah, exactly. So we have the Unicorn Hybrid Black suite where all the software tools are included. So the Unicorn Recorder, the different APIs, the Python API and Simulink interface, and also some application like sample games that we use with ERPs. Just make sure to download the Unicorn Suite environment, and you will find it on the GitHub with the link. And if you need some licenses, you can just ask us in the groups and we'll forward the licenses to you during the hackathon, and then you can use the device. We also have interfaces for network protocols like UDP and LSL. So a lot of people use it in different projects to make sure that they interface their own developments in other environments with UDP or LSL. Also check out the GitHub or come forward to us for questions. And with that, I will already start my demonstration of the Unicorn Hybrid Black suite. So let me check if everybody can see it. Okay, I hope everybody can see it also online. If not, just comment something if something doesn't work well. And I will also switch my video now, because I will ask Bernard to come sit here with me. So you can come here. So I hope everybody can hear me well. I will speak a little bit louder because I'm away from the microphone. But generally speaking, what we're going to do is we set up the device on Bernard, and then I will guide you around a bit in the software environment and show you how it works. So as I showed you already, the device looks like this. There is a power button on the backside, and if you press this a couple of seconds, you see it blinking, and then you know it's in. So it's turned on, but still not acquiring data. So what I have to do right now, I just put on the cap. So I'm just doing like this. The cap is a M size, mainly the ones that we brought. There are different sizes, plus the standard size is an M. And you just have to clip it and close it. And we have a reference and a ground that are marked with right and left, R and L. So just make sure where it's written, and you clip on those stickers. They're basically standard silver chloride ECG electrodes. And with those, you click them on the mastoid. So I'm taking here, not if we leave some space. Exactly, the mastoid is the bone structure behind the ear. We use it as the reference potential because there are less muscle interference, and yeah, it's good for us to have it as a good potential because we want to have here less artifacts. I also put on the other side. To get even better data, you can also prepare the skin a bit, but in general, it works like that with the stickers as they are. So that's how the setup looks. I'll come with the camera a bit more closer for the audience. Exactly. So Bernard is making sure that everything fits. And then I go through the software a bit. So I have here my device popping up because I already connected it. But you need to make sure that if you get a new device, to get a Bluetooth dongle going with your computer that is delivered with the Unicorn Hybrid Black, make sure that everything is set on green. So if I have my device connected, it needs to be paired just in the Bluetooth dialog, and then you can use it. For the licenses, so the standard recorder and standard packages are included. But if you need other packages like Python or the Unity, just ask us for the licenses during the hackathon, and we can provide them. We have a lot of different development tools here. On the side on the menu, you basically just get a link to the folder where the tools are stored. There are like sample scripts inside and the libraries and everything. And yeah, just make sure to have the licenses.
In the middle?
That's good, yeah. So actually Bernard just said, if it's in the middle, if you look at me and in the camera, maybe here's the camera, yeah, that it's just centered. Make sure that the cap is placed right. So we got also the right EEG electrode position as we state them in the manuals, because there are standard EEG electrode positions. It's just a cap with just 8 electrode positions. And yeah, we can open the Unicorn recorder. So with this one, we can just investigate the data as it is and do some basic recording and network streaming. So what I'm doing now, I'm gonna check the dry EEG of Bernard. So I'm just, if you press the run button, you just start it up and get 8 channels of dry EEG right now. So we have here actually quite good dry EEG. Just channel 2, I had some movement artifact. If you bite your teeth now, Bernard, you can clearly see the teeth biting, and you can also blink with your eyes. You can see in the frontal channels, so 1 to 4, because they are these ones more frontal, they get some EEG artifacts inside. And if you close your eyes now, Bernard, you can see some alpha activity, which is in the frequency range between 8 and 12 hertz, particularly in the more occipital channels, which are 5 to 8. So that looks good. So, and this is also how we basically always test the BCI system, the EEG system at the very beginning to make sure it's running real time. We get good data in, and then we can proceed. So maybe I can also show you the Oscar implementation right now without any gel, because if you move a lot, Bernard, now, maybe you can move your head also. Yeah, you see there is a lot of artifacts going on. But I'm turning on the Oscar now, and then I'm asking you to sit still for 30 seconds. The Oscar is our online artifact removal tool, which removes artifacts that are not supposed to be the standard EEG. So like it's trained on a time frame. It has a short time delay of 200 milliseconds, and you need to make sure to calibrate it for 30 seconds, and then it will remove artifacts such as movements, biting, ECG, and other typical artifacts in EEG. And after we kept still for a while, maybe we can wait 10 more seconds to make it settle. We just have a very short time delay. Then Bernard maybe you can now move your head again. Exactly, maybe you can bite very fast your teeth. So you see the artifacts are way lower, and maybe you can move even more. Yeah, and we also found with a lot of different experiments in auditory evoked potential, visual evoked potentials, that we still get the interesting data. So the AEPs, VEPs as we want them. we don't lose also alpha power by using the device. Maybe you can close your eyes. You can see also alpha activity with the closed eyes with the Oscar. So that's something that we use also, and you can use with the suite. And I will turn it off now. And then you see there is already a bit more activation. And now I will also show you how to fill gel, because for the basic lab experiment and setup, we just use gel because we want to make sure that the impedance is perfect and everything works fine. So I'm going to use gel. So we have standard syringes and water-based gel. I just fill in some of it, and then I make sure I'm touching the scalp and I'm moving the hair a bit away, because then it works best. And I'm just filling up. You don't have to fill up completely, just to make sure that the tips are having some gel below to get a better impedance. That's what I'm doing for all the electrodes. Remove some hair and also turn around the electrodes a bit so it touches nicely. That's how you prepare a standard EEG recording. Okay, I'm filling all 8 electrodes. Okay, so now I'm also moving them again, that the tips really have some gel below and we get a really good impedance. Then we need to wait very short to let it settle and see how the data looks. So it looks already good. And if Bernard is now biting again, exactly. And if you move now, move your head a bit faster, you see the artifacts are less because we have just a better impedance. Still, we have movement artifacts. We can also use the Oscar here. Obviously, it's also fine, but the data looks just better in general with gel. That's why I would just suggest you also for your experiments to run it with the gel. And now, after that, I will just stop and show you some possibilities that we have in this Unicorn recorder. So this is the basic recording software. I can record data to store it offline as a CSV or PDF file. So you can do that and then process it offline. And you can also stream it online with UDP and also LSL to your own application. So wherever you want to use the EEG in real time, you can use this networking. And that's how we basically use it. So for the channel assignment, please check out all the manuals. But if you have questions, ask us. But here you can see the assignment actually. So we have EEG, we have an accelerometer, we have a gyroscope, we have the battery, counter validity, and the trigger. So this is what you get from the device. The trigger is something, so the trigger is always important in EEG experiments to know when which event happens. So you can send triggers with UDP to the recorder, and you can send the data out with UDP, and the trigger is then saved in the last channels. But please check out the GitHub for details, and you can also ask us for that. And now I would like to show you some other applications that are also included with the suite. So we have different games, bandpower applications, which is actually interesting, and I want to show you, because the bandpower application is something that a lot of people use during the hackathon. So let us open this. Bandpower means just that we calculate here in real time the log transform power of different frequency bands. So we talk here about the frequency band that most of the people use when they do their own applications, neurofeedback. So we have here the alpha. So we start with the delta, theta, alpha, beta, and gamma, and we differentiate here different beta frequency ranges. And if now, Bernard, if you want to close your eyes for a second, you can see that the alpha goes up and the others go down. And if you open the eyes and maybe bite your teeth, you can see that the higher frequencies, for example, the gamma go up more if you bite them longer. Exactly, you can see that here the gamma, which is on top, is going up. So you can just see that we calculate the power online, which can be used, for example, if you use alpha, beta in multi-imagery or other purposes, engagement index calculations. whatever you want to use. And with that, we can, so we have here the calculation for all of the 8 channels in the different colors. We can do an average of all 8 channels. We also can do some other calculations with it. But what is important, and that's what people like about this application a lot, you can stream them again right away with networking and use them in real time with your own applications. So again, we use UDP protocol, and we just calculate over a buffer, like over 250 samples 1 second in this case, the power, but you can also set these settings and the sliding window, how you want to calculate your band power. You can set these settings here. Again, check the manuals or ask us how this works, and then you can get your band power samples for your applications. Exactly. So this is the Unicorn band power tool. And what I want to show you now is also a real application. So I guess a game would be nice. So we have a sample game. I will go a bit closer here. It's called the Brain Buddy. So I will open this. Do you still know how to play the game?
Don't remember.
Yeah, then we have to play it together because actually it's made to be played multiplayer. So it's a game that's based on ERP. So it's also something that you can build in Unity, as you've just seen it open in Unity. And then I will show you right afterwards how it works to build a game in Unity. It's just a 2D platformer game, and you just move close to the screen, exactly. And what we do now is we need to calibrate the system with the ERP. So you can look at the green circle and it starts flashing. And now we give Bernard some time to focus on it. So he needs to just focus on the flash. And with that, he will then guide through the game and remove obstacles, and he will be able to move forward if he focuses on the flashing objects in the game. What the game was actually built for was to use it in an environment where you have a multiplayer. So kids with ADHD or other disabilities in depending. So we have a calibration, so we have a classifier. So they play it with a friend or somebody else from the family, play it together. And I'm the friend now, so I will move with the keyboard, and Bernard has to focus on the circles, and then he removes the obstacles and I can move forward. So if he focuses nice enough, I can move on. He can also play it on his own, but it's designed to be a multiplayer game. And so what the BCI does is has a pre-selection with the white circle around, and if it's if you see the sprinkles, there were enough target flashes on it, and we have the selection, and then we can move forward in the game. And that's also what you can do with the Unity interface. You can just build your own platformer game just like that, or any other applications where you can also make different objects flashing, not just these green circles. You can also make yes, your objects flashing that you designed. So yeah, that's what we do here. Maybe we can just finish that because we're on a run. So this is one application that you can use it for. And after that, I will then, I guess, I will show you shortly again the GitHub page where you find all the resources. And then I will show you the BCI core, which is our newest system that you can run with the G.tec. So let's go. Nice core. Okay. Thank you.
And that's all.
Yeah. No, it's okay. You can take it off actually.
No, I would just keep.
Oh, okay.
Can you disconnect?
Yes, I will do it. Okay, so because Bernard wants to use the system then afterwards, I will just disconnect also in here. Yeah, so we yeah. Okay, then I will, let's see my screen. Okay, I will show you the
It's disconnected.
I will do it then. So I'll show you the GitHub. Please, for your presentations, switch the camera for a second. Okay, no, it doesn't matter. For your presentations, make sure to check out the GitHub pages and download the examples. We have a Google Drive that we will update with the groups that you can then upload the presentations. We have the templates here. We have the download links for the Unicorn suite that I just showed you, for other videos and tutorials, and also for the data that you've seen. That for the data projects, you can download your data sets here. Also in the GitHub, so like manuals and introductions, check out the Unicorn BI GitHub, and then you can find all the manuals and all the guides that you need to run your projects, with a lot of video guides and so on. And what I want to show you right now is the BCI core. So I will just open this presentation. Okay, wait, me change my video. Okay, so we have the Unicorn BCI core that looks like that. So it's our newest device. It's an 8-channel BCI as well, but it's more flexible than the Unicorn Hybrid Black, and we have it with different applications, and we use it with different base stations, as we call them. So generally speaking, the Unicorn BCI Core 8 is again a Bluetooth low energy wireless device. 8 channels with 250 Hertz output and 6 hours of battery time and a short charging time. It's a very light and small design, so you can see it here. It's very small, and we turn it on by plugging it with the magnet on the base station. So this is the amplifier, and this is the base station that is connected to the electrodes. We use it with different base stations, so you can see here the Sahara electrodes again that you have seen, the hybrid electrodes, but also gold cup electrodes and different technologies that are important for measuring it, for example, with animals or in other settings like sleep EEG. So the device itself has similar possibilities than the Unicorn Hybrid Black, but as it is Bluetooth Low Energy, we can also stream on phones and other devices. And what we do is human and animal EEG. So here you can see some examples from measuring EEG in animals. So we measured with horses and dogs and alpacas and a lot of other animals because it has such a small form factor and is wireless. And we have different electrode technologies that are just working better with animals. We have here, for example, examples in auditory evoked potentials in dogs. So you can see here this N100 very clear, more on the right lateral side in this case for the dog. That's what we already did a study about. And you can see here with the dry electrodes and here with the gold cup electrodes that you just stick on the below the fur, and you can record animal EEG. Also here with horses, similar setup. And we also did sleep EEG, so we can see we put it on the forehead, and we had very flat electrodes, and we did some sleep staging. And yeah, this worked also pretty fine. And this could be also an interesting application. We plot EPs, for example. So here you can see standard oddfall paradigm that you would do, also here recorded with the BCI core. And we get here a nice N100. And this would be, for example, visual EPs. So visual evoked potential experiments with different stimuli. So we have these grading stims, these checkerboards with high spatial frequency and low spatial frequency. And additionally, we put phase pictures, which are marked in yellow in this case. And you can see here the differences in the EPs. And yeah, also for the phases particularly, we have like this N170 occipital that is known to be phase representative EP. So that's what we tested with the device. And here also with dogs, similar behavior. We have also N100 for auditory EPs. So that was the experiments that we did. You can see here also the topography of the EPs on the dog scalp. So here on the right lateral side, the N100 was the highest. It was an oddball auditory experiment. This is horse EEG that we also used with video synchronization. So we can see, for example, people are interested in sleeping behavior, so they want to have it synchronized with the video. And now I want to show you the G-pipe. So Christoph already mentioned it shortly before. It's our newest Python environment for programming and performing BCI experiments. And we particularly designed it also to use it with the BCI core. So there is already a lot of documentation online on the G-pipe site. So you can check this out. And there are also a lot of tutorials and trainings and to get it started on your own. So the basic concept is that we have a backend and a front end. Obviously, we record the data, have different nodes where that we connect and process the data, and the main app shows the data, and you can visualize as you wish and just go through. There are a lot of examples. It's a very nice guide, and there is a big FAQ section. And I will also show you shortly now how the BCI core works. So I'll put it just on my head. So what we do with the BCI core, and that's actually also one of the main differences, we use it just dry. So it's just with dry. In this case, you can also still add some gel, but what we basically do is using it just dry. So I will we deliver a similar software environment than the Unicorn Hybrid Black. It's the BCI core recorder. So it's a similar environment. So I'm just opening the device here. Make sure that all the electrodes touch my scalp. Maybe I can ask Bernard to help me then, but it should be fine. So I have my EEG already here. I can bite my teeth. Close my eyes, I have the alpha, and if I blink my eyes, I have the eye blinks, as you can see. So that's how we use the BCI core, here all dry. And this is the suite. So again, you can do different filter settings and other settings, and you can again do the networking and recording settings with CSV, BDF. And as you have the opportunity with the Hybrid Black, you can do here similar approaches. And what I also want to show you very short is just the simple example in the G-pipe in Python, just so you can see how it can be run. We have, for example, here for the G-pipe, it's just a pip install G-pipe. You can see the documentation online, and we can use the package here. You just have the pipeline, and you do basic bandpass filtering, a notch filter, just basic filtering and signal processing that you can do with EEG. And then you connect those filters, and then you just add the front end, and yeah, you can start up the application with the BCI core. And we have a lot of, so online we have a lot of different samples. And now you can see here the EEG streamed directly in the window in Python. So that's again, if I bite my teeth, if I close my eyes, you can see the alpha. I hope you can see it here. Yeah, if I move. Yeah, that's a simple environment, and that's also something that's very nice to prototype and to develop for you. So yeah, I have some BCI cores here. So if somebody wants to use it on site at the conference, I can definitely hand it out. Maybe even there is somebody having one of people who are just virtual online. Just close my eyes, you can see a big alpha, and then when I open my eyes, exactly, close my eyes again. Yeah, closing eyes, as you see, is always the to-go test for the EEG device. If it's in real time, if you can really see a change in the frequency power. Okay, so let me close that. I can still go ahead in my presentation to show you other options. Exactly. So what I just showed you was the PCI recorder. This was the environment with the white background that is included with the g.tec suite. And you can also then use it with our other processing platform in MATLAB that are already pre-built classifiers and also analyze the data in GBase Analyze or use it in the gpipe. And what the PCI recorder can also do that you will for sure do in experiments that you want to set up is the triggering. So we can have a paradigm presenter and send triggers from the paradigm to the recorder software, and then you save this data with the triggers as a CSV, and you can process them offline or send them again with networking to another application that controls something, for example, or displays something. And this is the procedure, how this looks. So we have the presentation of the paradigm, for example, here, visual evoked potential, and it sends the triggers to the PCI recorder, records the data, and this one can send the data and the trigger to another platform and then process it. And for the Python, we have, as I already showed, the basic packages in Python you can use. And yeah, it can be customized very easy. So I guess it could be interesting for you to test out. So yeah, this was actually the biggest part from me. I guess we have still quite some time left over. Let me check. Yeah, now would you be ready to present something?
Yeah.
Okay, let me check, otherwise I can still. How are we in time? Please, if I can go through the GitHub, otherwise if we still have a lot of time. Okay, then we do that. Okay, so I will just go through the GitHub and all the information that you may need, and I will let the EEG run in the background just so we have something to watch. Okay, so okay, let's put this window here so we always have some EEG. Basically for the BCI core, the GitHub is also kind of our manual. So if you have questions also on the device, check first the manual online, and it will explain you basically everything. And if you have more questions, just come to us. What it shows is the channel setup, how you mount the electrodes, and what options are there, for example, with the animal EEG. And also the device handling, what the LED status means and how you attach it. So that's also something very important with the hybrid electrodes. You will have this with the electrodes on the cap, because you may want to use different electrode positions. You need to know how to mount it. So check it out. And also we have here this standard positions that we use for the device in general, but you can always use different positions.
Maybe we can stay here. So our convention is always for all the EEG recordings that are done, that you are looking at the head from behind and above. Then we start on the left frontal position. So this would be electrode number 1. And then we are counting to the right, 2, 3, 4, 5, 6, and you are going backward. So this position would be the last in the numbering. So in this case, this is the first electrode. This is number 1. Then 2, 3, 4, 5, 6, 7, 8. When you're counting in this way, you always know which electrode number is where, and you can identify electrodes. If you're not completely sure which electrode is which, you can just put your finger on top of it. The electrode showing most of the noise is the electrode that you touched. Maybe you can make the EEG screen a little bit bigger. So very important for EEG recordings is that neighbors must look familiar so that you know that you're recording EEG. So electrode 2 and 3 are about 5 centimeters apart from each other. So this is the second and the third one. And you can see they look very similar, but not identical. If they look identical, then you have a shortcut. So there's too much liquid between your electrodes and that's producing the shortcut. But if I look in detail, for example, this peak is visible here and here. So it's a clear indicator that these electrodes are close to each other. On the other hand side, electrode 8 is here, completely somewhere else on the scalp. And then you see this trace looks completely different from electrode number 2, as it should be. The Leo is closing the eyes again. So this is producing alpha. You can see the alpha mostly over the visual cortex. It's located on the back of the head. And because he is closing the eyes, the visual cortex becomes inactive. And alpha is a marker for inactivity. So we see these alpha bursts mostly on electrode 7, 8, 6, which are over the visual cortex. If we are decoding finger movements or leg movements, then we need the central line. So electrodes 2, 3, and 4 are decoding movements. If we would place electrodes on the forehead or on the visual cortex, we would never decode movements. So electrode position is super crucial for running brain-computer interface experiments. Please go ahead.
Okay, thank you, Christoph. Very good explanation. Yeah, so basically with the device, you can use it in different settings, and we will also soon provide a headband that has 4 channels that is also supposed to be released soon. And for the GitHub, for the hackathon itself, I just want to guide you through and maybe also show you the presentation template. Yeah, so I will need to check it out. You can check it out, the template. And also please then go on the download for the Hybrid Black suite. This it's 150 megabytes, so make sure you have good internet, and also for all your data sets. Go here and then you just start the download for the data sets. If you have any questions, go to the Discord. So we have an overview over all the groups, and we'll answer you as soon as any question pops up. And yeah, make sure that you really keep the presentation to the time, and also upload the video on the Google Drive. So you make sure we have all the information of all the groups. That's very important that we can go through the final Zoom meeting where the presentations are very fast, because there will be a lot of groups and everybody is supposed to present his work. Yeah. So, well, that's basically it from my side.
You maybe start the Unicorn recorder again?
Yes.
Just to show you something.
Yeah.
In the meantime, if there is a hosting institute in Mexico, for example, they have so many teams, so it would be nice if you're using the same computer for all your presentations, because then we don't have to change computers for all the presentations. So Leo is now selecting the serial number of the BCI core. Each device has a serial number. That's also important here in the room, because otherwise you're analyzing the data of another team. So make sure you are connecting with your own Unicorn. You can also see here these 8 EEG traces that Leo already explained, but beside that, you can also see this green and red color. So this is a quality indicator telling you if the EEG is good or not. Green is good, red is bad. And if Leo is blinking, for example, then you see this movement or eye movement artifacts mostly on the frontal channel, simply for the reason that the eyes are closest to channel number 1, which is located here, and the eyes are pretty far away from the electrodes on the back. So if you're not doing anything, then after a few seconds, you can see the settle to green. And if I ask him to bite, then we get this muscle contamination on all the channels, and the indicators for the worst channels turns to red. It just takes 1-2 seconds for the signal indicator to change from green to red or white or vice versa. That's a very good way for checking the data quality. So don't calibrate your brain-computer interface if not everything is green, because then you're training on artifacts, and this is something that we don't want. For the calibration during the real-time application of the brain-computer interface, it's not really important because an artifact is mostly a few hundred milliseconds, and the PCI classifier can neglect it, so it's not really a problem for real-time applications, but for calibration, it's super important. Okay,
Okay.
thank you very much.
Thank you, Bernard.